Gravity from above. One of the most fundamental forces in nature is gravity. It is the physical attraction of matter, and its force may accurately be measured by using a variety of equations. However, why are people so convinced that gravity pulls? Could there be a basic set of equations that considers gravity as a pushing force instead? Perhaps it is a force from time itself. Sir Isaac Newton. The story of Newton and the fruit tree is well known. He was sitting underneath and then saw a fruit fall. He wondered why. What he claimed was there was a force that attracted the fruit to the earth. He then made equations. Common equations. Some of the most commonly used equations when calculating the force of gravity is F equal ma and F equal to big G, big M, little m over r squared. F equals ma is good for when comparing a much smaller body to a larger body, and the force of gravity is already well known. F equals gmm over r squared is great for celestial bodies within the galaxy. Very quickly, F is the force of gravity, which is related to the masses of the objects and distance between them. But the universe is expanding. That's simple enough. However, at extreme distances, say the length of the universe, these laws aren't really applying. Intuition would tell us that the universe should be contracting, or at least slowing, in its expansion. However, it is still expanding. From this, it is obvious that something is missing, or that it is being approached improperly. Consider now the source of gravity coming from an outside source instead of coming from the mass of the object. Maybe it's from above. Yes, let's pretend that gravity comes from above instead of the Earth. How could that work? Electromagnetic waves carry momentum with them. You can physically move objects with lasers. A perfect example is getting a piece of lightweight tinfoil and shining a powerful blue light at it. The tinfoil will jump. So, maybe the force of gravity comes from light. Even more added energy could be coming from particles or photons when you consider all the relative frames of motion. How could this work? Imagine a free-floating body in space, not near any planets or stars. The force of gravity is zero, because there are no stars next to it. It is neither being pushed or pulled in one direction. This does not say anything about where the force of gravity is actually coming from. All it says is the forces are balanced, all adding to zero. This body could have billions and billions of tons acting on it, but all the forces are canceling each other to make no motion. All the stars in the universe. Here is a case that has a free-floating body in space. There are still billions and billions of stars and a smooth cosmic background for this example. Either these stars have zero effect on the body, or they have their natural effect. I would argue that they have their natural effect. Each star in existence emits essentially every wavelength in existence, from infinitely short to infinitely long. Each star pushes on the other, and you could say that space and time is dense with electromagnetic waves. In any point in space, there is essentially every wavelength of light coming in from all directions. There is a sort of universal mesh, and the universe is like liquid light in that fashion. Now let's add a massive planet to the scenario. What would a planet do to light coming in from all directions? The answer may be obvious. It would get in the way. So you see, a planet or any physical body is actually blocking light. The planets and other masses would be acting as shields. A new definition for gravity. The force of gravity could then be equated as interstellar star pressure, P, minus shielding, S. The interstellar star pressure would be the force of natural light waves in any point in space and time, and would not be constant in the universe. It would depend on the numbers of stars and varying wavelengths, all creating a general light state. Your equation would then look like F equal to P minus S. This is a very simple equation and works wonders in the universe. Not only does F equal P minus S, but F equals gmm over r squared for close ranges. So you could assume that F equals gmm over r squared is equal to P minus S. Remember, the answers are already there. The force of gravity will always be 9.8 meters per second squared for Earth. Therefore, P minus S of Earth is equal to 9.8 meters per second squared. All the answers are already out there, and it may help to redefine our methods for some scenarios. The approach. The rate of expansion is known from observations. The force of gravity at relatively close distances is known. From this, we could find that the value of p at any point in space, p is equal to F plus S. So what is S? Well, S is the shielding force, which is created by any mass as it blocks, or rather interacts with interstellar light pressure or energy. By using many different examples of known gravitational forces, we may approximate a reasonable interstellar P. Just like the equations for gravity that exist, the amount of shielding pressure would be related to the amount of mass and the distance squared. P would be the summation of energy of all light in space and time, including those of different relativistic frames. This would give a vector account of star pressure and direction. A simple example would be to say that P is at maximum at the center of the universe, where it is being bombarded by light from all directions. The resulting energy is equal to zero because all the forces would cancel out. Then you could say that at the edges of the universe, the total force would be due to P because there would not be any shielding sources. In short, you could say that shielding is equal to zero at the edges and the expansion is due to an interstellar star pressure of sorts. Relationship to expanding universe. Now to relate this to the expansion of matter at extremely large scales and the compression of matter at extremely close. Objects near one another are essentially pushed together. They have equal forces acting on them. However, objects near the edges would want to be pushed apart. It's a very simple concept that explains how the universe could be expanding yet matter is attracted to itself. Points where S is equal to P would be turning points of physical attraction or repulsion. Walking through walls. Have you ever wondered if you can walk through walls? The idea may seem like fantasy. All evidence in your day-to-day life says if you walk into a wall, it will stop you. Well, that is not the case for particles such as photons and neutrinos. These objects have the ability to pass through objects without any interactions. Why then may a photon pass through a wall and not a person? The main problem is interference of magnetic energies between photons or particle and the electrons in the shell of the atom. Here is the theoretical solution. Wave nature of light. Light is a very tricky guy. It can be seen as a photon, which has mass, or a wave, which does not. Very quickly, a wave of light may be comparable to a wave of water at the beach. The wavelength of the wave is the distance from one wave to another. The frequency is the number of waves that would pass by any point in a second. There is a direct relationship between wavelength and frequency. Building waves. Waves are awesome in many ways. One of the most interesting features is a wave's ability to add and subtract from another. If you were to have two waves of the same exact size but in opposite directions to where the top of one wave perfectly matches the bottom, then the two waves would cancel out. Much energy could exist, but there would be no physical indication because the two waves would be nullifying each other. However, after they pass, the two waves would return to their normal state, and you'd see both of them traveling away as if nothing ever happened. Bouncing waves. Waves have many interesting properties. One of them is that they may bounce off of barriers or objects. Have you ever noticed an echo in a canyon? It is essentially your sound wave bouncing off of different objects. Light waves can bounce as well. However, for right now, we are speaking in terms of sound because it is the easiest to relate to in our day-to-day lives. Another easy example to see in nature is in water waves. You can see this as water waves bounce off of channel walls. Next time you see water bouncing off a channel wall, watch as the bouncing waves overlap with the incoming and form nodes. Standing waves. By using the knowledge of how waves build and how they bounce, it is possible to create standing waves. A standing wave is a wave that appears to be frozen in time. It is the result of perfectly timed overlapping waves. Standing waves have many unique characteristics and may be used for many applications. Nodes of low pressure. One fun usage of standing waves is for the levitation of objects. Objects want to be in zones of low pressure. You can then control an object by controlling a node of low pressure. You can make the object go higher, lower, to the side, or whatever else you want to do. It really just comes down to being able to control the node. Standing waves can vary in length and size. The number of waves available for any system typically depends on the size of the container and what is in the container. Let's say the container in this case is a swimming pool that is 10 feet long. We now create one wave that is 10 feet in length. You will see that you have created one standing wave with one node. Now let's send a wave that is 5 feet long. You will see that you have now created two standing nodes. This trend continues for every common factor. If you want 4 nodes, then you just divide 10 by 4 and you get a wavelength of 2.5. The point, and I stress this point, is that there are common wavelengths in which standing waves may form, and those depend entirely on the size of the container and the velocity of the wave. These common lengths could be considered factors of the total length of the container. What's interesting about waves is that they are somewhat independent of the medium. Yes, the medium does control the speed at which the wave may travel, but the medium does not control the source of the wave. Imagine a pool of water. It has no waves. The water is just sitting still and being water. However, if you were to essentially massage the water in just the correct fashion, you could make a hole to where someone could pass through without getting wet. We could potentially make a swimming pool that floats in midair. The elements. The elements are a creation of particles. Typically, there is a nucleus that contains protons and neutrons, and then an electron shell that contains electrons. A simple example of an element is hydrogen. Each element is characterized by the numbers of these particles. Hydrogen has 1 electron, helium has 2, and so the numbers of electrons and protons determines the size of the atom. For our purposes, it would be directly related to the size of the swimming pools from the example before. By creating standing waves in the elements, it is possible to change the phase or spin of magnetic energy associated with it. Similar to moving water up and down in a swimming pool, we could move electrons and protons around with electromagnetic waves. A common factor. Just like swimming pools vary in size, so do the elements. Imagine you have 2 swimming pools but only 1 wave machine. How do you get the swimming pools in sync? You would need to find the common factor. This will allow the 2 different pools to carry the same standing wave energy. You could theoretically find the common factor of several pools to have them all in harmonic phase with one another. This may also be true for the electromagnetic waves in elements. Each element has its own orientation and size. By finding the common factor of electromagnetic energy, we may be able to tune them to one another. In other words, we can make a wall that has all the particles electromagnetically in phase with each other. The easiest way would be to imagine if we had a wall composed of a solid element like gold or iron. The diameters of these metals are already well known. We could create a standing wave within the material that composed the wall and then do the same with a rod. We would essentially have the rod and the wall tuned to the exact same phase, and theoretically, the rod may be able to pass through the wall with absolutely no interference. Manipulating gravity. Using our new theory in gravity along with the concept of space preparation, we may now theorize on manipulating gravity. This would be our ability to create more or less gravity in a desired location. Consider the force of gravity comes from an interstellar star pressure or overlapping of waves. Could there be a way to manipulate these waves? The answer is yes. Through our understanding of waves, we know that they will either add or subtract from one another. The light state of the universe. Consider the concept of a light state within any physical spot in the universe. Light state could be considered the total amount of all the electromagnetic waves that is passing through that point. Light state would vary at each point in the universe because of relative shielding and pressure sources. It could be considered a sort of snapshot of the electromagnetic state. The liquid light state universe. This really does lead to the question, is matter just nodes of overlapping electromagnetism? Does it even make sense to say that gravity exists? Could it be a resultant illusion created by space preparation? All waves overlap and their energy adds and subtracts. Matter is always in a constant form of manifestation, blipping in and out of solidity. Is it not just temporary waves passing through and continuing onward? Are we not peaks of the same wave? Does the photon not only become matter to another photon when the conscious observer is accelerating at light speed in the same direction? Let's continue on our conscious journey as the liquid light state universe examines the universe as if it is all light. Matter forms at nodes of overlapping electromagnetism. We also discussed the conscious field and light state harmony via the Cartesian mind, body, and spirit diagrams.